Hey guys, welcome back for this series. Today we will be doing an attack, a projectile basically. So far we have wired the tower to actually damage the enemy instantly. Here what I want to do is actually create a projectile which will move toward the enemy, and then it will actually deal the damages when it reaches the enemy. So this is going to require a little bit of refactoring regarding the tower, and also it will require us to create a projectile. Okay, so here let's actually create a new object, a new 2D object, and this is going to be a projectile 2D. So we can save this in its own folder, projectile 2D. For this projectile to be a little bit more visual, we can add a texture for it, and I didn't do one, so I'm gonna create a new texture. Right, so we do have a new SVG, and we can create a sprite 2D to add this little projectile here. Okay, now that we have a scene, we actually need a script. So let's create a script for this projectile. So let's see, what we need for the projectile is first, well, to actually know how much damages are going to be dealt by this projectile. So I'm going to have a public int damage. We also need a target. So here we're going to have a public node2d target. Regarding the situation we have right now, we can actually say that we want the target to be an enemy 2D. This seems fine to me. And also at the same time, we will also need a constructor to allow us to create those projectiles easily. So here, public static scene or packed scene path. Okay, as well as a oh, I forgot to say that it's a string. And we also have a public static projectile2D method, which is the constructor, right? Exactly like we did in the create projectile. In the enemy spawning episode. Okay. So I'm gonna do just like last time. I will separate this code in two parts. So we have the public partial class, Projectile2D, and here we have the non-static code. Okay, so we have the damage, we have the target, and at some point we will need a move, so a public void function, move toward targets. Let's start feeding those things a little bit. So here, so we're gonna copy the UID right here and set it for our string property. And so far we'll just return the usual resource loader, load, packed scene, and here we load the packed scene path. And we instantiate this as Projectile2D. Okay, so this is the base version of the constructor, right? Where we just load the scene and return it. However, it is gonna be necessary for the object here, the Projectile2D, to have two crucial informations: the damage and the target. So it's not something that the projectile can find on its own. It is the tower's responsibility to give the projectile those informations. So either we can, have the tower manually edit those properties when the object is created, or we can inject those properties within the arguments of the constructor, so that we make sure that we don't create projectiles which are missing properties. So here we're gonna have an int damage, And we're also gonna have an enemy 2D target. It is necessary to actually assign those arguments here. So we're gonna have a Projectile2D, which is gonna be Projectile2D. So I usually also like to use the name node, right? That makes it quite short. So we have the node, and this node dot damage is going to be equal to the argument damage, and the node dot target is going to be equal to the argument target. And once it's all set up, we can return node. Okay, so the damage and the target are technically set up now. So all we have to do is to think about what exactly is the projectile going to be doing. And here it's going to be moving toward the target. And once it has reached the target, it will deal damages. So in order to control the movement of an object, I don't think we did that so far. We actually need to use a few things. We need a direction for the movement to occur. So a direction is a vector that points toward where you want to go, and more specifically it is a vector of length 1. It is important that the length is 1 because we actually want to be able to apply the movement speed and actually know exactly how far the object is going to move in the specified direction. So in Godot you have some functions which allows you to get directions directly, but here we're gonna do it kind of manually because we will be using the global positions just to be sure that we actually don't break anything. So when you want to get the direction to something, you actually first create a vector from where you are to where you want to go, right? So you create that line between those 2 points. And this line you get it by actually taking the final point and you subtract the origin point. So we get the global position of our target X, and we do subtract the global position of the projectile we have. So here we do subtract this. Then we do exactly the same with the Y value. So we have the target dot global position Y and global, what did I say? Global position dot Y. Alright, so here we have the vector which defines the entire trajectory. So what we do is we call the normalize function, and now this vector is actually reduced to a length of 1. And then we actually want to multiply the direction vector with the movement speed to actually know where we're going. However, there's a slight catch here. This is going to happen every time we do update the game. The game is actually updating every frame, right? And not every frame is going to have the same time between 2 frames. So here what we're going to do is we're going to create what I call a delta movement speed, which will be a kind of final product using how many time elapsed since the last update and how fast I should move to get this final movement that you must add to your projectile. So here we're going to create a float which is going to be the delta movement speed. So this is going to be equal to movement speed multiplied by delta. Delta which we need to receive from the process function, right? So here we're going to have a float delta argument. Actually, delta argument. Alright, so we have the direction, we have the delta movement speed, so now all we have to do is to actually apply the calculation to the position of our object here. So let's create a new vector 2, which is going to be the new position vector. So here we're going to have a new vector 2, and we're going to need to actually... So for the x value, what we're going to do is we're going to take the global position dot x of the projectile, and we're going to add the direction dot x, which we will multiply by the delta movement speed. Then we will do exactly the same thing, global position dot y, and we're gonna add direction dot y and delta movement speed to it. Now that we do have the new position, all we have to do is to set the global position of our object to be the new position vector we have created here. So this is the move method. Now we have been using an argument delta, so we kind of need to have the process function actually calling this method to make the projectile move, right? So we're gonna override the physics process method, and here it has a double delta, and as you may have noticed, we're actually using a float delta. So what we're going to do is move toward target like this, and we're going to cast as a float the delta argument. Right, so here we have converted the double into a float so that it matches all those calculations here. So we're almost done. The projectile is moving toward the enemy, but at some point the projectile must disappear and actually hit the enemy. So let's say that the enemy is around 18-16 pixels of the projectile, and then we actually decide to remove the projectile and instead hit the enemy. So for the sake of the series, I will be using distance calculation between the projectile and the enemy. So this is possible because the projectile is specifically targeting one enemy in particular. So if you actually have different power systems which use AoE attacks, that's not really how it's going to work. But here let's see how we can do that with distance. Let's create another vector 2, which is gonna be, let me think about the name here, something like trajectory. And basically the value of this vector is going to be exactly this thing we have calculated before, right? The trajectory here, except that it's not going to be normalized, right? So here we have this trajectory being calculated. Now we're going to use methods to calculate the actual distance of this, and here we're going to make that. You're going to make an if statement that says if the trajectory dot distance, no, length maybe, yes, length. So if this inferior to, let's say 18, or let's say 16 actually. So if the trajectory length is inferior to 16, then we're actually not going to move the projectile. So we're going to return so that we don't proceed to do that. We will actually do something different, which is like, you know, apply damages attack. So here we're creating a new method, void apply damages. It's going to be very fine. So let's call this apply damages method. Here, well, first thing, at some point we will want to queue-free the projectile so that it is actually removed from the tree. But more importantly, we want the target, and here we should have a damage function, right? We have a damage function where we can give a damage argument, so here it is. So eventually you may have thought at some point that we didn't set the movement speed, and that is true. So I'm gonna initialize this to 200. So here I really want to make sure that the projectiles are faster than the enemies. Eventually you may want to make sure that the projectiles accelerate as the time passes by so that they are not outrun by the enemies. But yeah, here let's just stick with 200 float. Yeah, by the way, I don't know if I said that, but the F here is just to say that we are defining a float and not a double. Okay, so I think we are actually quite good with this projectile. All we need to do is to make sure that the tower is using this projectile instead of instantly damaging the enemies. So let's actually go in our tower script here, so Tower2D, And we should have something which talks about damaging the enemies, right? Yeah, attack. And here we are using enemy and we do damage to this enemy. So instead of doing this, we're gonna remove that and we're gonna create a new projectile. So we're gonna add a child to the tree, which is gonna be a Projectile2D dot create projectile. And we need to give two arguments, the damage and the enemy. I think it's actually all we have to do here, right? We just replace the old attack with this and that should be good. Let's save everything. Let's make sure that we run the world and see how this works. So it is kind of slow, okay? So eventually we can speed this attack a little bit. So let's see, what if we give it something like 800? Yeah, it's a little bit better. So we can see that the aiming is a little bit random and we can see the projectiles going off. So at the moment with the targeting system that we have, it is actually possible technically that the turret is going to throw an attack at an enemy who's actually already dead because the attack is not existing anymore. It is actually important to think about this. What happens when the enemy is actually dying while the projectile is moving toward it? So there are two things to consider. The first one is that we must make sure that the projectile is actually able to kind of, notice that and say, all right, so the enemy has been freed, so I'm gonna disappear as well. So since this is very important, we're going to do this right here, and this is not going to be an exercise, but here we will basically override the ready function, and we're going to create, watch a signal, which is going to be the target, and here we want the free signal somehow, so we just need to make sure that we catch the right name. So if we go pick, well, any kind of scenery, so let's pick the enemy 2D. We have tree exited or tree exiting. So let's go back here and find tree exiting. And we're gonna add a new thing. Well, I'm gonna add a new method. Okay, so here, let's create a public void on target freed. Do something very simple like Q3. Okay. So here we can just say on target freed. Okay, now let's actually talk about an exercise, which I'm not going to do in this video today, but you can think about this. That's totally up to you, and if you manage to do that, it is again a very great step. Here, basically, the exercises try to make so that when the tower sends an attack to an enemy, and the projectile is going, and it will reach because it will never miss. Make it so that if the projectiles are going to kill the enemy, then the tower doesn't throw extra projectiles to this enemy in particular, right? So find a way to do that. So that's all for this little animation episode. I hope you did like it. As usual, you can do all the things, liking, commenting, and if you do really like what I do, you can always drop a super chat or even become a member. You have no idea how this can help me on the long run. Anyway, you take care, and I'll see you in the next video or in the stream if you want to pass by.